Hello everyone. We are going to review chapter 4, switched networks. First we are going to discuss about converged network. What is a converged network? Converged network is a single network that provides multiple services like voice, video and data through a single network. Converged network. In continuation to converged network, we will discuss Cisco borderless network. Cisco borderless network has a lot of features. It allows an organization to connect anyone, anywhere, anytime, on any device at the same time, securely, reliably and seamlessly. The Cisco borderless network provides the framework to unify the wired and wireless access. The borderless network framework includes network access policies and access control methods. Borderless network framework is responsible for performance management across many different device types. Borderless network provides network services, user and endpoint services. These two services are managed by an integrated management solution. Hierarchy in the borderless switched network. The borderless switched network is developed in terms of multiple tiers, which has multiple layers. The borderless switched network design guidelines are developed based on the following four principles. The four principles are hierarchical, modularity, resiliency, and flexibility. Hierarchy. The hierarchical principle provides information about the role of each device at every layer. The modularity allows the seamless network expansion and integrated services. The principal resiliency provides always-on available network. It manages the network failures by using the redundant path or alternate path. The last principle, flexibility. It allows an intelligent traffic load sharing. If you have multiple paths to the destination, it will choose the best path, it will choose the shortest path, or it will choose the alternate path if the path is not available or if the path is congested. Converged network has three layers. I forgot to tell. This converged network, this hierarchical layer network is divided into three layers. Core layer, look at here, core layer, distribution layer and access layer. Now we will discuss about these layers one by one. So there are three layers in the hierarchical model, namely access layer, distribution layer and core layer. Access layer provides the network access to the end devices. Access layer provides network access to the end devices. Layer 2 devices are involved in access layer. The access layer connects all the end devices together. Now we go to the distribution layer. Distribution layer, it acts as a bridge between the access layer and the core layer, or it interconnects the core layer and the access layer. The distribution layer provides many functions. The distribution layer is responsible for aggregating or grouping layer 2 broadcast domains. The distribution layer also aggregates the layer 3 routing boundaries. Distribution layer provides intelligent routing and switching functions, also network access policies to access the rest of the network. Now we move on to the core layer. The core layer is the backbone of the network. It provides fault isolation and high-speed backbone connectivity. One more thing I want to tell. If you see the smaller network that do not requires this separate distribution layer and the core layer. Those smaller networks use a two-tier network, or the smaller networks will use a collapsed core network design. So that means it has the access layer, and this distribution layer and core layer are collapsed or combined into a single layer. So which is a two-tier model which is suitable for a smaller networks. Now we'll discuss about switching or frame forwarding. When a LAN switch receives a packet, it makes decision based on the two criteria. Assume that this is a switch. The switch receives the frame through a port, through the port number 1. Now, in the frame, it is mentioned that the destination address is EA. Now, the responsibility of this switch is to forward this frame to the destination address EA. So, when a LAN switch receives a packet, it makes a decision based on two criteria. What are the two criteria? One is ingress port, another one is destination address. As I said, what is the ingress port? The ingress port is a port where a frame enters into the switch. Now, the switch receives the frame through the port number 1. So, port number 1 is the ingress port. And in that frame, the destination address mentioned is EA. I already said that when a LAN switch receives a packet or frame, it makes the decision based on two criteria. That two criteria are, that is the ingress port number and then the destination address. Right. So what is ingress port? It is a port where the frame enters into the device. Now, a LAN switch, all the LAN switch will maintain a table. The name of the table is port table. In the port table, we have two fields. One is destination address and its port number. Which destination address is associated with which port number? So the destination addresses are mapped with the port numbers. When a LAN switch receives a frame from a device, immediately it will check the destination address in the port table. Say for example, now the switch is responsible to forward this frame to the destination. So through which port it will forward the frame? Here the destination address is represented as EA. Immediately the switch will open the port table and then it will check where is EA. So EA is associated with port number 4. Now the switch will forward this frame through the port number 4. So through this port it will forward the frame. So this is the outgoing port. We can call this port as a egress port. So the switch is responsible to find out the egress port, outgoing port. After that it will forward the frame through the egress port. Now we will discuss about frame forwarding or switch forwarding methods. There are two frame forwarding methods are available. They are store and forward switching and cut-through switching. The store and forward switch receives the entire frame from the source and then it computes the CRC, cyclic redundancy check. If there is no errors in the cyclic redundancy check, that means if the CRC is valid, the switch search for the destination address, and then it determines the outgoing interface, then it will forward the frame through the egress port. If you see the cut-through switching, the cut-through switch forward the frame before it receives the entire frame. As soon as it started receiving a frame, it opens the header part of the frame and reads the destination address and immediately start transmitting the frame to the destination. So, if we compare these two forwarding methods, the best forwarding method is, we cannot say because there are many parameters are there. Store and forward switching is having some advantage, cut-through is having some advantage. Store and forward switching is reliable in that no errors will occur, whereas in cut-through switching is very faster, but there are chances for occurrence of errors. Now we come to the collision domain, switching domain. If you see the switching domain, it is called as a collision domain. In a hub-based Ethernet segment, network devices will compete for the medium. Due to that, the collision will occur. Ethernet switch ports operating in full duplex mode avoid the collision because it has a separate channel for sending, it has a separate channel for receiving. So when an Ethernet switch port operates in full duplex mode, it will avoid the collision. There is no chance for collision. Whereas if the Ethernet switch port operates in half duplex mode, definitely there is a chance for the collision. Ethernet switch ports will auto-negotiate a full duplex if connected to a full duplex device. For example, a switch is connected with another switch. The switch A is configured as auto-negotiate and switch B is working in full duplex mode. That means the switch A is configured as duplex auto, the switch B is configured as duplex full. That means switch B is working as full duplex mode, switch A is working as auto mode. So when you connect the switch A with switch B, the switch A will negotiate with switch B. The switch A will ask switch B in which mode you are operating. If switch B replied that I am operating in full duplex mode, then switch A will also operate in full duplex mode. Okay. For example, another example, switch A is configured as auto mode, duplex auto mode. Switch B is configured as half duplex mode, duplex half. Okay, half duplex mode. Now switch A will negotiate with switch B and it will operate only in the half duplex mode. Broadcast domain. One or multiple interconnected switches form a single broadcast domain. So now you can see here a broadcast domain. So this is a broadcast domain. Switch is a broadcast domain. Layer 2 devices are broadcast domain. Okay. When a switch receives a broadcast frame, it forwards the frame out of each other through each other port except the incoming port or except the ingress port. When two or more switches are interconnected together, okay, the broadcast domain is increased. If you see here, the two switches are interconnected. So what happened? The broadcast domain is increased. And then too many broadcast domain will cause a network congestion. So that is a drawback of this.